So this says, number 10, given the triangles below, prove that they are similar. That's what that little symbol means. So remember, there are only 3 ways that you can prove triangles are similar, either by 2 angles, by comparing all 3 sides, or comparing side angle side. And if you look at ours, the only options we have are all 3 sides. So this is the one that I'm going to try and show right now. So in order to do that, I'm going to set up 2 columns. I did not mean to do that. And since I'm going to compare the sides, the first thing I want to make note of is you want to compare the biggest to the biggest. So that's where I'm going to start first. So the largest side on that side is 24. And that I'm going to compare to the largest of the other side, which is, or other triangle, which is 16. And I'm just going to change that to a decimal. And the reason why I'm allowed to do that is because they gave us those numbers. So I'm going to do that for all 3 sides. And when you do that, you will get 1.5 for each one of these. And since these ratios are all exactly the same, we know that the triangles have to be similar. And since they gave me all of these, and again I compared the big side to the big side, the little of one triangle to the little of the other, and the medium to the medium, since they gave us all of these, we know the triangles are similar because of side-side similarity. So I'm a little bit out of room. I'm going to try and write it over here, and then I'll erase it for the next problem. So we know triangle PTR is similar to triangle XVY, and that final reason is because of SSS similarity. It's a little hard to see because I have things overlapping, but in question number 11, this says we have a rhombus with diagonals, and one thing that's important about a rhombus is those diagonals always meet at 90 degrees. In fact, all 4 of these triangles are exactly the same. They want us to find the area of the rhombus. Well, I see 4 triangles. There are a couple ways to do this. But the way that I see it is I want to find the area of one of the triangles, like this one, because this one gives me the base and the height. So actually the 17 I don't really need, because the area of a triangle is base times height divided by 2. So I'm going to find the area of one triangle, which is 8 times 15 divided by 2. So now if we want to find the perimeter, we just have to add up all 4 sides, which is 17 times 4, which is 68. So again, to find the area of the rhombus, to find the area of one of the triangles using base times height over 2, and then just multiply by 4. So the area is 240, and then to find the perimeter, you add all the outside together. In question number 12, they tell us something very important at the top, and that is that AB is parallel to CD. And when they're parallel, we have corresponding angles. So if you notice, we have a little triangle that looks like this and the bigger one that looks like this, so those angles would be equal to each other. We also have corresponding by C and A, which gives us these angles. So we know by AA, which is what this says right here, explain how you know they are similar. I would say they are similar by AA. If you wanted to label them, which would be a good idea, for sure A and C are congruent, and we know that D and B are congruent. Then they want us to solve for x, and we can do that because they're similar. So on the bottom I have a 4 right here. On the side I have a 6. On the other triangle at the bottom I have a 6, and the whole side, remember you're trying to go all the way from P to D, you add that and you get 9. So now that the triangles are similar, I can set up proportions. The 6 goes over the 9 the same way that 4 goes over the x. And make sure you go in the same order each time. So I'm just going to cross multiply and solve. So when I cross multiply, I get 6x equals 9 times 4 is 36. So x is 6, which is the length of this. Number 13 says we need to solve for x given that the two lines are parallel cut by a transversal. And first they want us to name these angles. So hopefully you remember these are called same side interior angles because they're on the same side of the transversal. And they happen to add to 180. So I'm going to add 5x minus 29 plus 3x minus 23 to equal 180, and then I can solve for x. Combine your like terms, add 52 to the other side, and then divide your answer by 8. So the final answer for x is 29. So this question starts by asking us first to plot the points, which I did below to form the parallelogram ABCD, and then they want us to answer the following questions. So part B says find the area of the parallelogram, and hopefully you remember it's basically like a rectangle. So we need to know just the base and the height. And to do that with my graph, I'm just going to count the bottom. So if you notice this distance all the way from here to here, that's a total of 6 boxes. And then I have to count straight up. So from the middle, I'm going to count up 1, 2, 3, 4, 5. So the height is 5. So then the area is just 6 times 5, which is 30. The next part says if angle A is 3x plus 10, that's right here. So that's 3x plus 10. And angle B is 2x. That's that angle. What are the measures of each angle? Well, hopefully you remember that those add to 180. So I'm going to add 3x plus 10. They're called consecutive angles. And in a regular parallelogram, if you remember, this angle and this angle add to 180 degrees. So I'm going to solve for x by setting it equal to 180. So I solved for x over here, and I got x was 34, but remember they want us to find the measure of each angle. So I need to plug 34 in right here to find angle A, and just substitute it in, and I also need to plug it in for B. So I'm going to do B because it's easier. 2 times 34 is 68, so this angle must be 68 degrees, and the other is 3 times 34 plus 10. Which is 112. So angle A is 112. If they asked, remember opposite angles are equal, so the angle C would also be 112, and angle D would be 68, and all 4 angles would add to 360. So my final answers for angle B after I took 34 and substituted in, I got 68 for angle B, and I got 112 for angle A, and then I put in the opposite angles as well. This next part says plot the image of the parallelogram after this transformation and list the new coordinates. So when you do that, all you have to do is substitute them in. So I'm going to plug in a -3 there and a -1 there for the x and the y. So for A, I'll get a -6. And the y value is a -1 plus 3, which is a 2. To do B, I plug in the 3, and you get 6. And you plug in a 1 for y, and you get 4. For C, I'm plugging in a 1, and I get a 2. And then I plug in a 4 and get 7. And the last one, I get a -10. and I plug in a 4 and I get another 7. So I'm going to plot this real quickly for you. Hopefully you were a little more careful than I was and you noticed a little mistake. When I copied the coordinates, I had copied B wrong, which is 3, -1. I wrote it down as 3, 1. So when you plug that in, you should have 6, 2, which is right here. And they want to know, how is this compared to the original one? So if we look back at the original shape, hopefully you can see that it's not the same shape. It's actually a non-rigid, and we want to know, was it a dilation, was it a vertical stretch, a horizontal stretch, or a translation? So I'm just going to look back at the two pictures together, and hopefully you can see that it is stretched out longer this way, but the height is still the same. The height is still 5. So that's called a horizontal stretch.